Hi, welcome to our next video on the quadratic formula. Right, the quadratic formula. Well, this is a formula that helps us find all solutions to a quadratic. There have been three scenarios that have occurred when solving a quadratic equation. Scenario 1, two real solutions, and we're going to talk about a new word called roots, two real roots. Scenario 2, two repeated solutions or two repeated roots. And scenario 3, where we have no real solutions or no real roots. It all comes down to this part of the quadratic formula, the b squared minus 4 times a times c, which is given a name, the discriminant. And this is the part that can help us to determine what scenario we have when we're solving a quadratic equation. If we have the discriminant greater than 0, like our first video on the quadratic formula, we have two real solutions or two real roots. If we have the discriminant coming out to be exactly 0, that was our second video, and we got the discriminant to 0, and we plus 0 and minus 0, we end up with two repeated solutions or two repeated roots. The same answer, basically. And finally, we looked at in the last video where we had no real solutions or no real roots. That's because the discriminant gave us a negative number. It was negative 135, and we can't take the square root of a negative number. Right, let's have a quick look at what's going on visually. So our three scenarios based on our discriminant. When we have scenario 1, the discriminant's greater than 0, remember a quadratic forms a graph called a parabola. And here's a parabola here, and we have two real solutions because the quadratic, the parabola, passes through the x-axis twice. When we have scenario 2, the discriminant is 0. We have two repeated solutions or two repeated roots. We have the quadratic, the parabola, touching the x-axis at one point, and that's what we mean by two repeated. And finally, when we have scenario 3, we have no real solutions or no real roots. The discriminant is less than 0. We have the parabola that does not touch the x-axis. So our three scenarios are based on what's going on with the parabola, whether it touches it twice, once, repeated, or doesn't touch it at all. Okay, well, we've got an example to finish off this video. It's one example, but there are millions, not quite millions, there are lots of different scenarios when it comes to this idea, and you need to go back and look over all the exam papers and other texts and stuff, because there are lots of different ways this kind of question will be asked. It's normally tested at the excellence level, could be a really difficult merit. Here's our example. The equation 3x squared minus nx plus 5 equals 0 has two distinct roots. Find the values of n. So our job is to find what values of n will make this equation having two real roots, two distinct roots. So here's our quadratic formula. The values of a, b, and c. A is 3, b is negative n, we don't know that yet, and c is 5. Right, be careful with the negative n, which makes positive n, and also be careful with the negative n all squared. Negative n times negative n makes positive n, which is n squared. So, once we've simplified it down to this expression, let's have a look at the discriminant, the bit inside the square root, n squared minus 60. Now we were told it's got two distinct roots. So coming back to our three scenarios, that's another way of saying two real solutions, two real roots. So we're looking at scenario number 1. So we need to say n squared minus 60 has to be greater than 0, because that's scenario 1. So let's now solve this inequality. N squared is greater than 60. And when we go and square root it, be careful, because a number squared has two solutions. So that's why we have greater than 60 and less than negative 60 as our two possible answers. Now what does that mean visually? It means any number that is greater than 7.75 will work, and any number that's less than negative 7.75 will also work. Thanks for watching.